Welcome to Basins and Beer with ESA Analytics. I'm Blue Spikes. I'm going to discuss our new software application that we just launched, and I'm also going to talk a little bit about the San Juan Basin, which is a region in primarily southern Colorado and northern New Mexico. I got the name Basins and Beer from a series of talks I gave in Denver last year, so I thought I would adapt that to a web series where we discuss some of the same things. The beer I chose today, I'm going to show you the box because it's a little bit easier to read. It's Avery's Old Jubilation. It's an English-style old ale. It's kind of a Christmas theme, so I've already cracked my can and taken a sip. I can tell you it tastes great. I mean, it tastes a little bit like Christmas. I do like this style of English ale, so if you want to get out and try this, I encourage you to do so. To jump into our application, you go to earthscienceagency.com. You have to have a subscription to get into it, but once you get to the website, get your subscription going, you log in, and it's going to take you to a page that looks exactly like this. And this is the entire application, all in one dashboard. The first thing you can do, if you haven't been to the application before, is open a map of the United States, and you can look at some nationwide data sets just to get a sense of coverage. So this is a map of counties in the United States showing how many wells are in each county. This shows where we have data currently. We expect to finish Oklahoma by the end of the month, and then we'll move east and we'll fill in California. I think by the end of 2025 we'll have the entire country filled in. And so we'll be adding roughly a state, maybe two states every month. Some of the bigger states like Oklahoma take a couple of months, but we're almost done with that. And as you move east, you get into states that are more verticals and less horizontals, so they tend to go a little faster. You can get a sense of where most of the wells are drilled with this kind of map. You can see Texas is obviously where there are more wells than any other state. Wyoming has a lot of wells. You get over here into Colorado, a lot of wells. Kansas has a lot of wells. And if you want to break it down by state instead of by county, you can do that. Turn off the county layer, turn on the state layer. Again, this shows over 1 million wells in Texas, over 400,000 in Kansas. Colorado has 122,000. Wyoming has 200,000. New Mexico has 132,000. And from there, the numbers start to drop. Utah has 38,000. You get out to Nevada, there's only 1,000. So you can see the main thrust of what we've been working on is in this mid-continent and Rocky Mountain region, because that's where the majority of the oil drilling activity in the United States is. Now there is quite a bit over here as you go to the east. California has quite a bit, and there's quite a bit in Alaska, and of course we've already covered North Dakota. But really, most of the activity is in this region. We will get to these. We're just not quite there yet. You can also look at regions. So turn off the state map, turn on the regions. So this is how we break it down, because there are too many wells to load in at the same time. So each of these regions represents a different geologic province and different wells and different formations that you would be targeting. And operators tend to focus in one or two or three of these basins. So this is a useful map, and what it tells you is which region you might want to investigate. So for example, in this case, we're going to come over here to the San Juan Basin, which is right here. So again, northern New Mexico, southern Colorado, and to load that basin, you're going to go to the regions pull-down menu, and you're going to go to San Juan. Oh, the wrong one. So the way we built this app, it sort of tells you what you need to do in order. So in the upper left, the first thing you need to do is load your region. And normally you want to then color by some property, but let's look at the map first to see why you kind of want to color by first. If you don't color by anything, you just get this kind of bland looking image with a bunch of well spots. And while it's significant to zoom in and see exactly how many wells there are, which even though this isn't one of the biggest basins, I mean, that's a lot of wells in one small area. So uh, even without any coloring, you do get that point across. But now let's color by formation. Now you start to see some patterns and trends that it's helpful to evaluate. And if you open the sidebar menu, you see it instantly populates a bar chart that you can sort of zoom in and scale. And this bar chart serves as a legend for all the colors out here. And you can see using this bar chart which formations are the most common. So the Fruitland and Dakota are the most common. You see the pink and the gray. And then the Mesa Verde is next. And then the Gallup. And then you get some other formations as you continue looking down, where you have fewer and fewer in each formation. When we talk about what is the formation, these wells cut through multiple formations and they often produce from multiple formations, but we try to boil it down to just one formation, which is the primary or the producing. And in cases where there's more than one producing formation, we choose the deepest producing formation. And in cases where there's no reported producing formation, we either map it ourselves and kind of figure it out based on the perfs, or we just take the deepest reported tops that are known to be producers, and we call that the producing formation. And then over time, we will continue to refine those estimates where the operators didn't report it, so we need to come up with an answer ourselves. We already have a very good start, as you can see in this basin, which we haven't put any particularly large amount of time into. This is one that we've worked on some, but we didn't focus on this a whole lot. This is just what emerges after our general cleaning, gathering and cleaning routine. And you can see it's already pretty good. You also get a scatter plot off to the side. The scatter plot's really nice because the axis label down here, which is, it starts by default with producing length, which is from the top of the producing interval to the bottom of the producing interval within a well. And if you want to change the data along that axis, you just open this pull-down menu right from the axis and you choose your new variable. And you can do the same thing over here with the y-axis. There's a table that you can view, which I think is a very useful way to view this kind of data. So we can look at a little bit more of it if we turn off the map, turn off the sidebar. Now we can see the full table view. And so if you're a real data guy like me, the table view is essentially where you're going to spend a lot of your time. But it's a little bit prettier and more interesting if you open up the map. So some people will spend most of their time with the map open. And then other people really like to multitask and you get everything open. One of the things I want to show you is how to filter down to a different set of wells. So right now we're showing every well. Let's say we want to just look at horizontal wells. So we use the filter, choose the direction, there's a pull down menu, and go through that process, and now I can see all of the horizontal wells. So you can see that this center of the basin is dominated by empty space, which means that's probably all vertical wells. The horizontal wells are off to the sides. So one thing we can do to really visualize these horizontal wells is to look at the surveys. So the surveys tell us exactly where those wells were drilled horizontally. So that really provides a lot more insight versus just one dot, which would be the surface hole. You can also get a sense, let me zoom in here, and I'll choose the lasso tool, and I will choose these wells. So this allows me to select a specific set of wells. So you see all the other wells are still shown, and they're all still in the table if I scroll down. But the wells that I've selected have now been pushed to the top of the table, and they're highlighted in green. that's important just for your own ease of use. One thing you want to do with a horizontal well, because it obviously goes down and then turns, is you might want to look at the subsurface view. Like, what does it look like underground? So I can focus on one of these wells. Let me see which one that is. So when I mouse over it, it highlights it, and it jumps to that row in the table, which was this row. So I get a sense of where that well is, so I can find it a little more easily in other tables. You can see it's also over here in the scatter plot. I don't want to spend too much time on it. So in order to switch to a different well that you're highlighting, you have to hover over it for a second or two, and then it switches. That way it doesn't rapidly switch as you move over, which is how it used to work, and that was pretty annoying. So having it sort of pause, like if you pause on a well, that's when it jumps to it in the other graphs. So now by focusing on the well, I've said, all right, give me all the data in the subsurface that surrounds this well. So now I can look at the subsurface. All right, so that's pretty cool. This reveals two things. One, you've got this, what looks like probably an error in a survey. So right here, this is an outlier. So now I know that we need to troubleshoot that well. So I'm actually going to write down that API here, so bear with me. Okay, so now I can go in there and I can troubleshoot that well and fix that. But the other wells obviously look really good. And what you also have over here is a gun barrel, which shows the distribution. If you're looking at these wells, it's as if you're looking down this view in the 3D model. And then below that, you have sort of a side view, which is looking at it, from the side. So that's kind of cool. You can zoom in and see how this well fits into the stratigraphy. So jumping out of the subsurface view, we can also look at production. So looking at all of these wells, this is the cumulative production. So you can see they all came online for almost the same amount of time. They all end at the same number of, these are plotted in days. So they've all been online for anywhere from 650 to about 800 days. So if you want to look at the date to actually see when they came online, you can choose date, and whenever you change something, you have to hit apply. They all, like the first ones came online in about April of 2022, and then there was one that came on, and maybe a couple more in here too, that came on in later in 2022. But they're all drilled in a similar time frame. And you can see in this graph, it also shows how the well production came up after it was completed, peaked, and then it's been declining ever since, which is a pretty standard expectation for these oil wells. They're going to come online, they're going to produce the most in the beginning and then decline over time. You can also see how when this one came online, it affected the production of these others. Now, they may have shut these in, or maybe this stole some of the production from those during this time. If you did a little further investigating, you could, within our application, you could figure out were these shut in during this period, or was this sort of theft by the new well. So jumping out of the production view, I want to give you a sense of how you would drill down and try to create a meaningful map using this application. So I want to go ahead and close this. I want to get out of this horizontal filter. So these wells, I'm still showing horizontals. It's just now all of the other wells are also visible. I don't want to select any wells. So now there's no longer anything selected. You see this one's still highlighted because it's still focused. And if I mouse over this one, I can highlight that one. I mean, that's just kind of a neat thing that you can do and move around the basin and highlight different wells. But what I want to show you now is a map of the subsurface depths. So I can scroll in here, and I want to now plot by formation depth. I'm going to choose the fruitland and hit apply. So what this is essentially a subsurface map. This is a structure map of the depth of the fruitland formation. So the fruitland formation is the biggest coal bed methane producer in the world. And so this is a very interesting formation, and it's a real focus for companies that are drilling in the San Juan. Over here, right now we're plotting by producing length and BOE. I want to maybe change this to gas, see what that looks like. And maybe instead of producing length probably works. So let's leave this as gas and producing length. So because this is these are cumulative gas numbers, you can see that there's quite a distribution. You get a lot of gas being produced with these wells with shorter producing intervals, which means they're probably verticals. And then you get out into the longer producing intervals. These are probably getting into laterals. So this bar graph, I had to double click it. It was still sort of registering my earlier data. So a lot of times you can reset these graphs by simply double clicking on it. So this bar graph shows you the distribution of these depths. So you get most of the depths, most of the wells drilled are sort of in this 3,500 to 3,900 range. And this is TVD subsea. But anyway, the point of this kind of visualization is just to show you how a lot of data put together looking at the same variable can be very revealing from a spatial point of view. So this looks like a structure map, even though it's really not. We haven't contoured it, we haven't gridded it. This is just TVD subsea depths for each well for that one formation. I think that's really all I have time for today, so I'm going to wrap this up and just say if you want to learn more about ESA Analytics, come to earthscienceagency.com or keep tuning into this channel and I'll post more videos. Cheers. You all have a good day.